Okay, so we're going to take another look at that law of sines very quickly. We're going to look at the ambiguous case, side-side angle, or what some people call angle side-side, if they kind of want to use the shock value that's there. So don't forget that when you deal with the law of sines, our big story here is that the sine of any angle divided by the side that across from it is the same as the sine of any other angle divided by what's across from it. So kind of going through the story this way, what I wanted to do is imagine, if you will, that we have a triangle where I have the measure of some angle A is, I kind of rigged something up so I had some numbers to start with. Let's say it's 48 degrees. And I have some side opposite that thing, and this time I'm going to go ahead and go with the side A is, let's say, let's see, 11. And so the last little piece is I'm going to do a couple of different problems all building on this. So the first one I'm going to do is, let's imagine that I tell you that B is some extra value in there, and let's say that it is what did I just do? 15. Let's say it's kind of think for a second here. If that's 48 and I make that one 11, let's go ahead and make this side right here, let's say 8. Just a simple little value. So the first thing that we do is I draw a triangle, and any time that I'm suspicious that it's going to be one of these side-side angles, I always start down here and I call this one 48 and this one is going to be 11. I personally like to make B coming this way, wrapping in this version. So the problem is sometimes the triangle may be redone a little bit different, and maybe it's possible that instead of drawing this side 11 out this way, maybe it comes in this way, producing an obtuse angle in this little corner right here. So what I'm going to do is I'm going to come into this little problem right here, and I'm going to try to solve triangle number 1. Assuming that this is going to be an acute angle. And again, that may not be a safe thing to assume, but I'm going to start with that idea. And I'm going to then say that the sine of 48 over 11 is equal to the sine of B over 8. This time I'm not going to do the full cross multiply. I'm just going to multiply both sides by 8 because that leaves this sine of B sitting all by itself, which is really all I needed. So 8 sines of 48 divided by 11. So right now I have that the sine of B is this number. So I'm going to take the inverse sine, and I got that B is 32.7 degrees. Now for this particular video, for the sake of being a little shorter, please understand that we can continue this process, because as soon as I have that value for B, I could take 180, I could take that B away and take away 48, and I would know that this angle C up at the top is 99 degrees. And we could do the law of sines one more time to find C right here. So for this video, I am not going to finish this, but we would do it one more time and say sine of 48 over 11 equals the sine of 99.28 over C. And you could finish it. This is a great triangle. There's nothing wrong with this. I just didn't want to take the time right now. But if there is a triangle number 2, but keep in mind this is ambiguous, and as we talked in class, sometimes this triangle happens and sometimes it doesn't. So what we're going to do is we're going to take this first angle that we found, calling it B1, we're going to find B2 over here. And that alternate version of B, you always take 180, and this is the first angle we found. We take that away from 180 degrees, and I got 147. Well, that's not possible, because if we have angle A is 48 degrees, we're already over 180 degrees with another angle to go. So there is no such triangle over here. So although this triangle is good, this triangle is terrible. So there is one valid triangle. Okay, pretty simple little idea. But what if now we changed it just a little bit and we said A was 48, again, just like before, little a is 11. But what if we made side B 14? Well, now what happens? So let's just again go through the process. So we come into here and we say that A is 48. We say little a is 11, B is 14. It's sitting here like this. And now we go through the same process. The sine of 48 over 11 equals the sine of B over 14. Now again, I'm going to go a little quicker this time. 14 sines of 48 divided by 11. And then I'm going to take an inverse sine. And I got that this measure of this angle B is 71.053. I'm going to store that as B again, so I have it for later. Let's add that to 48. Let's take that away from 180 degrees, and I got 60.946 degrees. This appears to be a very nice, simple little triangle right here. Again, all of it's known except for this one. So just like up here, we're going to do the law of sines one more time. But what if there was a second triangle that came in like this? So the relationship that I went over with you and why I stored that number is I'm going to take 180 and I'm going to subtract alpha b. And I got that this angle right here would be 108.94, I guess 947 degrees. Well, there's absolutely nothing wrong with that angle being 108.947 degrees. I'll add that to 48 and then I'll take 180 and subtract. But I have a whole new value set right here that totally works. So again, just like over here, I now have two triangles that work as opposed to one triangle that works. And I could just use law of sines a third time because that's what it takes. It took one time to get this angle. We need one time to get this side, and we need one more time to get this missing side here, and we could find the second triangle. Now, the last case that happened, so we had one case, we had a two case. This is what the zero case looks like. And so, you set up your same problem that we've done a few times, and you got your 48 here, you got your 11 right here, and let's just suppose that this side right here is like 35. And again, I'm just making something up. It doesn't really matter. Here's A, here's B, here's C. And so we set it up just like we have. We're going along our merry way. Life is fantastic. That's not over C, it's over 35. And then we do one last little piece here, and we say, okay, well, that means 35 times the sine of 48 divided by 11 is 2.36. And when I tried to take the inverse sine, it says, no, you can't do that. And the reason why is because the sine maxes out at 1. It can never reach 2.6. There is no such triangle. So the problem is this side actually, if you literally drew it to scale, 48 degrees going out 35, then 11 is only about, say, that long. It isn't long enough to reach the bottom. And so that's the case where angle side produces no triangle of any kind. So that's a real brief look at the angle side story. But what you'll notice is it always works if the angle side, if this side is larger, there will be one triangle. It's if this side is smaller, that's when the bad things happen. Either there will be one triangle like this, two triangles like this case right here, or possibly no triangle at all in that case if it's a little bit too short. So it's really when that second side in angle side is smaller that strange things start happening. Now, as I mentioned before, we also have the ability to look at that software. So again, I looked at this a moment ago. We can clear that data and we can say, well, what if I decided I wanted A to be 48, little a to be 11? And we'll just go through those problems. Then the first question, I said it was 8. And you'll notice it says, oops, I put that in the wrong place. It was actually side B was 8. And notice it says SSA or ASS. It's a unique solution. And this matches actually what we did. But when we changed that missing side from an 8 to a 14, we said there were two triangles. And this software also shows that there's that second case. Notice it says two solutions. And then finally, if I tweak that one last little step and I made this side 35, now it says that there was in fact no solution. So that's the end of our ambiguous case. Let me know if you have any questions. Hopefully that helped.